Next question, sorry. Transition element properties. So we can say that they form compounds that are colored. So we can say they can have variable oxidation states. So they can have many oxidation states in their compound. You can say that they make good catalysts. So think about your Haber and contact process, for example. And then there are obviously some other obvious one as well, okay? Iron is used as a catalyst in the Haber process. They do not want you to describe the process. They want you to name, because it's part of a case study. But it's actually to make ammonia. So Haber process make ammonia. Next bit, you are reacting iron. You're reacting copper 2 sulfate. So copper 2 plus SO4 2 minus. There's your sulfate. This one your formula is that. FeSO4 for the same reason. Fe2 plus SO4 2 minus. You get copper there. But you want ionic equation. And when you have sulfate anion and you have sulfate anion, these are what you call spectator ions. They appear on both sides of the equation, the left side and the right side, because you're talking about aqueous solution. So you do not put spectator ion into ionic equation, yeah? So iron plus copper 2 plus give you iron 2 plus copper. If I was being specific, ionic equation is always accompanied by state symbols to clarify it, but since they didn't specify, I don't think you will be penalized if you don't put it there, but it's just a habit of mine, really. Okay, observation that you will see. The formation of copper has a distinctive different color than iron. So you also have this solution which is colored and this solution which is also colored. This solution is very pale green. So you need to be careful, yeah. This is not a precipitate because you are not in hydroxide. You are not adding NaOH. You are in water. Fe2 plus in water is a little bit pale green solution. So there is a pale green solution, very light, in fact it looks like colorless. This, however, is a pale blue solution. I should have used a blue color, but I can't be bothered really. Okay, so what happened is you will see a solution color changes. Solution color changes from pale blue to kind of colorless or pale green, but so pale green, not a precipitate, yeah. This is not a dirty green. This is not in hydroxide. This is in water. The pale green solution, and the color of this is actually a pink solid. So copper looks a bit pink, and pink solid is deposited, or you can say is formed or observed. To distinguish iron 2 and copper 2, so now you can add sodium hydroxide aqueous, and this one will now give you dirty green precipitate is formed. So that is now iron 2 hydroxide. This is in water, this is in hydroxide. Water is H2O, hydroxide is OH minus. Different, yeah? This one is going to be a pale blue precipitate is formed. And that pale blue precipitate is copper 2 hydroxide. Okay, next question. Next bit, balancing equation. They didn't say balance equation, but any equation that you write in chemistry, try to balance. No, in fact, not try. You have to balance, otherwise you will be penalized. Iron 3 oxide, so it's iron 3 plus or 2 minus. So in terms of valency, you know that you need to balance out the charge. So it's like plus 3 multiplied by 2, minus 2 multiplied by 3. That's why you have 3 for the oxygen and 2 for the iron 3. So you add with dilute sulfuric acid, you can make iron 3 sulfate. Now think about this. The Fe2 goes to the Fe2. The SO4 goes to the SO4. There are 3 of that unit now. Therefore, 3 of that unit. When you first started balancing equation, you will have work out the individual number of atoms. But as you become experienced, you get to see that this is the whole SO4. It's got 3 of it. This is the whole thing SO4. You got 3 of it. I mean, that's the easy way of balancing it. You got to balance it now with H2O because, trust me, it's not balanced. Where does your hydrogen and where does your other oxygen here go? Your SO4 goes to here, no problem. But your oxygen here, it has to go to the water. So now you have 3H2, 3H2, 3O, 3O. If you forget the water, you are done without a balanced equation. Yeah. Distinguish iron 2 and iron 3. The sulfate is the same, so it's iron 2 versus iron 3. So this is your paper 3 again, but in paper 1 and paper 2, you are not given a table of results. You really need to know your chemistry very well. Otherwise, not only you will struggle in paper 3 because you will keep on relying on the table that's provided, you will also struggle when you move on to do higher level chemistry. But simple test here, you just add aqueous sodium hydroxide. You should know this from your practical. Or you can say add aqueous NaOH, is the same. The iron 2 will give you a dirty green precipitate. Shouldn't use the word PPT because you're not doing practical here. Sorry, the other one will give you a brown red kind of PPT. It's kind of like rust. And I suppose you should know that it's insoluble in excess NaOH. And this is also insoluble in excess NaOH. I mean, these are typical tests that you do in paper 3. But I don't think you really need it, to be honest. I mean, important thing really is the color, and it's a precipitate being formed. Form. I mean, you don't just write something without a proper meaning to it, yeah? So you add in dilute sulfuric acid with this Fe3O4. So this is quite strange, right? Fe3O4. Because it's a mixture of Fe as... I can tell you what it is. It's a mixture of these two. So you get Fe3O4. Alright? But what you don't know is these are iron oxide. They are a mixture of it, okay, which is not important here. So you can see it contains iron 2 and iron 3. Iron 2 and iron 3 is a mixture, yeah? Okay, so when they react with sulfuric acid, so meaning to say they are individual compound, when you react with sulfuric acid, what do you get? These are what you call metal oxides. What do you know about metal oxides? Apart from things like Al2O3, which is amphoteric, meaning it reacts with both acids and bases or alkali. These are normal metal oxides or transition metal oxides. We can associate most metal oxide can react with acid because most metal oxides would just be basic oxide. Alright? Just like group 1 oxide, group 2 oxide, they are what we call basic oxide. Right? They react with acid in a neutralization reaction, acid plus base. What you will get is you get salt. This is your salt number 1. This is your salt number 2. You will also get water because this is a neutralization reaction. Basic oxide plus acid, neutralization, salt and water. Oops, I cannot write formula. You gotta read the question, they want the name. So water is correct. I cannot write the formula H2O because they want the name. Alright? If they say identify, I can write formula because they don't say anything about identify, right? If they say name, then you have to name. If they say give the formula, you write water, that's wrong. You have to write this. Okay? Construct the equation for this reaction. Okay. Individually is easy to do. Alright? So I'm gonna show you what I meant by individual. FeO plus H2SO4 will give you FeSO4 plus H2O. That balance automatically. Fe2O3, which is iron 3 oxide, plus H2SO4 will give you Fe. Now you have Fe3 plus SO4 2 minus. As you know, your LCM of 2 and 3 2 and 3 is going to give you 6. Therefore, you need 2 of iron 3 plus, and you need 3 of iron. You need 3 of the sulfate, because this is only minus 2. How do you get to 6? You need 3 of them. This is 3 plus. How do you get to 6? You need 2 of them. This is LCM. You need to reach a common ground, right? That's what you learn in primary school. Okay, so that's Fe2SO4 3 plus H2O. Here's your salt and water. Your equation is balanced, is it? 2 iron, 3 sulfate. So I only have 1 sulfate here. So put a 3 in front. I have 3 H2. I have 3 times 2, that's 6 hydrogen. So I need 3 there. And my oxygen is 3. Guess what? Add together. Then you will get Fe3O4. When you add these two together, you will get Fe3O4. Okay, they are a mixture. That's why you get iron 2 and iron 3 individually. Yeah. Plus, when you add 1 plus 3 sulfuric acid, you get 4 H2SO4. And then you're going to get 1 FeSO4. You're going to get Fe2SO4 3, and you're going to get 4 H2O. I can do this on an iPad easily because I can move things around. So I'm going to move it to make it look a bit nicer. You have got a lot of space at the bottom. Why don't you use the space below to make things look nicer, and then you can put your final answer here. Alright, this equation is balanced because this was balanced. When you add them together, provided you do 1 plus 3 correctly, you should be able to get this balance straight away. Alright, you want to test for iron 3 ions. So this is a paper 3 practical, which you need to know here in theory, not just paper 2 but in paper 1 as well, and also in A-level. Yes, they do test you in theory paper in A-level chemistry as well. Yeah, so you can use ammonia, aqueous ammonia, or you can use sodium hydroxide. I'm going to use aqueous sodium hydroxide, which is NaOH. So Na plus and OH minus. Please know the formula. Yeah, so you will observe dirty green. Nope, dirty green will be iron 2. You will get a reddish brown precipitate is observed. And you need to talk about in excess as well. Okay, insoluble, in excess, and OH. Why do I need to talk about excess? Well, what do you do in a paper 3 to identify it? You add in excess, right, to see what happened? Well, there you go. What you do in paper 3 is what you need to know in chemistry, because it's a practical science. Okay, it's not magic science, it's practical science. All right.